So yeah, for everybody on the line, welcome to our October version of the GDS webinar series. And we, as just a quick reminder, this is a part of American Physical Society topical group on data science. We are the youngest member. We're the youngest unit within APS, and we're really established by a bigger vision that we can provide a common home, a home community for physicists that are interested in data science, and then for data scientists to find where their skill sets may be able to be applied in the physics research and education. As the youngest unit, we are also very sensible to the most recent discussions about diversity, equity, and inclusion. From the very beginning, from our inception, we tell ourselves we're always committed to fostering a diverse, equitable, and inclusive community where all of the members can feel safe and welcome. And I think this is especially important for the topic of data science. There is, we really believe that diversity and inclusion are at the heart of vibrant and productive science, such as physics, right? But then more than that, we're really, really sensible to know that, data science can be a powerful tool to address the diversity and inclusivity issues. And but this tool really has to be, very carefully applied to be really effective in the community. Now, we treasure diversity. We aim to, stress on that whatever we do. However, I wanted to stress that, as a young community, we're also learning how to do it. And fortunately enough, we are a data science community, and we deal with data. We analyze the data, and I really want to say that we really want to learn how to leverage what we know how to do to address this bigger issue about diversity and inclusivity. And that really leads to our discussion today, which is really learning about this evidence-based approach in in addressing diversity, equity, and inclusivity from our experts, right? So without further delay, I really want to welcome you to today's webinar, and also I look forward to the discussions that will happen today. And with that, I will turn it over to Kyle.
Hi everyone, this is Kyle Hall here, and I'm one of the organizers of today's webinar series along with G and Rachel Henderson. She'll be popping in later, and it's my great pleasure to be part of the group bringing this to you today. So we're going to have a couple speakers lined up who will be tackling these challenging issues of using data, understanding data, and then taking action in the context of equity, diversity, and inclusion. Before we get to that, though, just some brief housekeeping. Of course, we encourage you interacting and asking your questions. The way we're going to do this is there's the chat box. You should see it on the right-hand side there. Specifically the question box. You can put your questions in, and then we'll take them up later on. For ease, we'll actually go through both presentations first, both speakers. And it's going to be relatively short presentations, 15 minutes per person, so that we can have a lot of time for Q&A at the end. And we can then really dive even deeper into these issues, and you can really get your questions answered. So please, as we go through, add your questions to the question box there. And if we don't have time to get to them now, we'll address them afterwards. So, it's also important to remember that this is just one webinar, and that GDS has put on a number of great webinars at this point. This webinar, like all of the preceding ones, will be available on YouTube. So if you have to duck out partway through or know somebody who couldn't make today's segment, please pass along the link and that'll be distributed. So with that housekeeping out of the way, and of course, always staying connected, important to remember. Let's dive into today's topic. So evidence-based approaches to equity, diversity, and inclusion. So two speakers, as I said, Paul Walton and Danny Caballero, and they're going to talk about two different facets of this challenging and important topic. So without further ado, we'll turn over to Paul here, and I'll just give you a bit of a brief introduction about Paul. So Paul obtained his PhD in 1990 from the University of Nottingham in the UK, and he followed that with 2 years as a NATO Circ postdoctoral fellow at Berkeley. He joined the Department of Chemistry at York as a faculty member in 1993, and between 2004 and 2010, he was the chair of the department. And Paul has won a number of awards in teaching and research, very vibrant research program he has. The things I want to draw your attention to, though, are the awards that Paul has won for his work on equality. So he won the Royal Society's inaugural Athena Prize and Wise Man of the Year shortlist. Paul has also, in this space of being both a vibrant researcher and a champion for equality, Paul has served on the editorial board, or as the editor, of Dalton Transactions, and has won a number of awards and been the chair of different organizations, such as the Heads of Chemistry UK, and the chair of the Royal Society of Chemistry's Diversity Committee. Paul is well known internationally as an advocate for equality in the sciences and has lectured widely on the topic. And it is my great pleasure to introduce Paul today for his talk, Which Evidence to Use in Driving Forward Equity and Inclusion. And with that, I'll turn it over to Paul and hope you enjoy the presentation.
Okay, I hope people can see that. Okay. Just a second. Slideshow. Sorry, just one moment while I get myself sorted here. There we go. Got it. Okay, well, thank you very much for the invitation to come and speak today. It's a real pleasure to join you. I've been looking forward to this to chat about some evidence base that the evidence base we've been using in the chemistry department here at York, and actually nationally in the UK, to drive forward principally gender equality practices, but also more recently equality in LGBT and disability. And I should say, as time moves on, the various protected characteristics, gender, LGBT, age, disability, are merging more into one as time progresses. The other thing to tell you, as Carl mentioned, I've done quite a bit of work in equality, and this has extended over the last 20 years or so. So many of the things I'm going to talk about the use of data stem really from the experience of 20 years worth of work when it comes to gender equality. And perhaps if I was to condense that down into one sentence, is what have we learned about the use of data in driving forward gender equality, and really what works, or equality, and really what works and what doesn't work. So I'm going to start with this very simple slide here, and that is the types of data which are available to you when it comes to equality matters. And it turns out if you were to type into Google, for instance, the causes of, say, underrepresentation of women in, say, physics, then you will indeed find a lot of studies have already been done, and you can acquire an awful lot of data on studies out there. Moreover, you probably have your own set of studies which may well show either underrepresentation in particular areas, or even a representation, equal representation in different parts. However, when it comes to examining these these data, they break down into two classes, and those of you who are social scientists will immediately know what these two classes are. First of all, you can collect data on what you might call real-world studies. So these are These are studies done on groups of people, maybe your department, your university, your place of work, whatever it may be. And they would check a variable. So they'll say check something like age or progression, and they will break that down into a particular characteristic. So we could say male or female, or where you sit on the gender spectrum, or where you sit in terms of ethnicity. And I'll show you some examples of these types of studies and data and the use of data in a moment. These real world studies are great, but they suffer from confounding variables. And you'll know what a confounding variable is, but let me give you an example. If you to look at the representation of, say, female academics in universities as people progress up the grades, then the percentage of women as you get towards the top grade falls away. And the question is, why is that? And someone might say, well, it's because of unconscious bias or poor promotion rates, whatever it may be. But there'll be a whole bunch of other variables that could explain the trend that you see. So in other words, there's no killer set of data, that's the phrase I use, killer set of data to say what the underlying causes for data trends may be when it comes to real world studies. That's the first thing to say. The second thing to say is you can actually solve this by performing lab-based studies on what you think are causal factors in inequality or equality activities. And these have been done, and there have been many of these done, including some famous ones with orchestras where people were selected to play a particular instrument, but where the selectors couldn't see the musician. And those studies were then repeated where people could see the musician, and those revealed very clearly that there was, in this case, a gender bias in the way that musicians were selected by orchestras. However, the trouble with those studies is they're not real world, and they're false situations. They're situations which don't necessarily apply to what goes on around us in our day-to-day working practice. And as a result, those studies too do not provide what I would call the killer data or the killer indicator to show that there may be inequality or there may be inequity in a particular organization. And whilst that may sound like a disappointing and dismaying start to my presentation, I'm going to explain how you can work around this. Well, first of all, it's important to recognize that there isn't a killer set of data out there. There'll always be questions about data, but there are ways of working with the data set and the collections of data which do bring you to a point which will allow you at least to create a case for equality actions, and in some cases find out what the underlying causal factors are for what you might see as inequality. And what I'm going to do is just go through some examples of studies and the data and how we've used them in particular ways, and then also at the end give you some real live examples of data actually from my department at York here in the UK, and how that's driven particular types of equality change, and they've been particularly powerful. Okay, so I'm going to start right here. So one important use of the data, or one important use of evidence, I would say, is of course the literature. And I draw your attention to this particular example, which was published in Science in 2015. And whenever I see a paper on equality in science or in nature or in say PNAS, I always spend some time reading it. And I picked up on this particular study, which was a very interesting study, which went as follows. And this was in an academic setting. And people were asked to, and these are academics, people were asked to say how clever or how intelligent they thought people were in particular subjects. And I don't know if you can see the plots here on the right. On the bottom here is a plot of what you might call arts and humanities. And on the top is a plot of subjects which you might call science or mathematics or engineering. And the x-axis here is what the authors call the field-specific ability index or number, which was the result of them asking this type of question: which of the subjects, education, psychology, communication studies, history, blah, 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 do you think has the most brilliant people? And what you find is that other academics will say that it's the philosophers out there who they think are the most brilliant. And you can see that philosophy indeed as a subject is seen to be right here out on the right hand side of the plot, and you're seen to be a particularly brilliant person if you're a philosopher. And rather unfortunately, you see on the left there, if you work in an education department, and forgive me if you do work in an education department, you're not held in the highest esteem by your colleagues in terms of ability. Now, just keep that in mind for a second. I'll come back to why that's important in a second. For mathematics and engineering and science, the plot is at the top, and as you might expect, when people are asked where they believe the most intelligent and able people are, we find that we think the mathematicians are the most brilliant, and then the good news for you folks that the physicists then do pretty well. Chemistry, my subject, is less well regarded, and then if you're a poor neuroscientist or an earth scientist, then you're viewed by your colleagues pretty poorly. Now, of course, it wasn't the intention of the authors to dig out really what the reasons were for that. But what they did then, and you can see this on the plot, is they correlated, and notice my words there, they correlated that with the percentage of female PhD students in those subjects, and saw that there was an association between the belief of people, so no real evidence there, the belief of people of brilliance, and the percentage of men in the subjects. Now, why do I show you these data? I show you these data for several reasons. The first is that it's a well-founded study, and that the analysis that were done was carefully done and was carried out by experts. And actually, this reflects the wide availability of expert-led evidence on particular equality measures. Secondly, it shows that the best studies, the best forms of data are those which both have quantitative data and also in this case qualitative data. And in fact, the qualitative part of this is the x-axis and the quantitative part is the y-axis. And it's known that when you combine both qualitative data, so these could come from surveys, these could come from employee questionnaires, with quantitative data, the two forms of data together are compelling. And certainly in our case, this particular study we used quite powerfully in our work on unconscious bias, and being able to convince not all, but many of our colleagues that they may well too carry unreasonable or not evidence-based beliefs about the brilliance of people in particular subject, and that correlated in this case with gender. And when it came to trying to help people understand that they may well carry these biases, this particular study and its discussion with my colleagues was particularly helpful. Okay, so that was one. Let me move on to the next one. This one is interesting. This is an interesting set of data for a different reason. So ratemyprofessor.com, which is not a popular kind of website here in the UK, but I believe it is in the US, where students, and these are undergraduate students, are asked to rank or rate their professors for their teaching quality, and then usually say some fairly unsavory comments about their professors as well on this website. Now, this is an awful website for many reasons, but there's one good thing that they have, is that they've collected an awful lot of data on the ratings of professors by their students across a range of subjects. And you can see here on the y-axis, what ratemyprofessor.com did is they broke down the responses of students in their particular areas of expertise or their majors. So here's chemistry, and physics is near the top. And on the x-axis here, what was plotted was an index, a normalized index of how students scored their professor's teaching ability. Now, I'll stop there for a second and say that the student assessment of teaching ability is a critical factor in promotion and progression of professors in universities, and therefore it's an important number. Well, as you might guess, these ratings by students split down in terms of gender, and this is a case where the data were disaggregated in terms of male and female. And the blue dots were the average scores given by students for the teaching quality of their male professors, and here they are. And the orange dots right here are the average scores given by students for the teaching ability of their female professors. And you see that there's a gap. Now, you say, well, maybe that's not surprising because of what we know about the way that male and female professors are judged. And you can see the quote at the bottom there is that female professors are much more likely to be judged for what they wear and for the way that they act than male professors are. That's not the point. The point is that it occurs in every single subject. There's no exception. So from music all the way down to criminal justice, including biology, chemistry, physics, maths, a lot, in every single case across this large data set, we find that there is a split, a disadvantageous split for female academics or female professors in the way that their students assess their teaching ability. Now, of course, this is not free from confounding variables, not least of which is you might expect that the age of female staff that are being assessed may well be less than that of male staff, given that we have a legacy of dominance of male academics in our universities. But nonetheless, the point is that no area is free of the difference in assessment of staff by their students. And this is an example of the use of data where we've drawn from many different subjects or many different dimensions, and they're all telling the same story. There's no exception to the particular message. Okay, I'd like to move on to this next set of data now, which, I should go back and say, in this case, we use these data powerfully to get the university to change its approach towards promotions of academic staff, and to basically take qualitative comments by students on feedback with more suspicion than they had in the past. This set of data here now is another set of interesting data which has been used by us to drive forward the cause of equality within our university. And it was published a couple of years ago. You can see the reference at the bottom, and please feel free to have a look at that. But this is a study which was done of research papers, and you'll notice at the top it was done over 1 million research papers, and this study has the advantage of it being a large data set. And for each of the research papers, what the authors did was they gave an index, and that's on the x-axis, of the diversity of the authors or the co-authors on the paper. Those indices broke down to in terms of ethnicity, that's the top left-hand plot, age, gender, and then affiliation is where they came from in the world. And then to take those data and see how they were correlated or associated with the mean 5-year citation count for those papers, for which they had indices. And in every case, and notice my phrase again, in every case where a diversity index was chosen, whether it was gender or age or ethnicity, there was a positive, sometimes weak, but nonetheless positive correlation with the performance of that paper or that research paper under the normal metric of a 5-year citation count. Now, why do I show you this? Because I show you this because this is one of the few examples where we can find good evidence, not killer evidence, but good evidence that diverse working groups within universities, and this is well known for companies, but less so for universities. Diverse working groups for universities do lead to higher performance under citation metrics, and if you're prepared to stretch that a bit, to higher academic performance overall. And this set of data, along with some follow-up studies, were influential in driving forward some more positive action statements from the university, so where I work, in employing a wider range of staff. And you'll notice actually the strongest correlation of diversity, which leads to higher citation counts and perhaps therefore academic performance, is actually ethnicity. And it appears that ethnicity, or diversity in ethnicity, is powerfully associated with the performance, certainly, of universities in research. What data have we also used actually within my department when it comes to driving the cause of equality? And this has been particular gender equality. And I'd like to show, and we've used lots of different data in many ways, but I'd like to show you two which have been particularly useful for us, and I think have focused the argument in many cases so that there's action that has followed. The first one is a plot you'll be familiar with, and this is a so-called leaky pipeline plot, and I'm going to have to translate this here from English into British English into American English, but this is the grades, academic grades, as you go from college student, undergraduate student, all the way up to, this is what in the UK is a full professor, senior lecturer is an associate professor, and lecturer is an assistant professor, postdoc is your typical kind of researcher. And this is across all subjects in UK universities. The red line here then tells you the percentage of women as you progress up those grades. And well, you see what I think we've all become very used to is that as you progress up the grades within university, we see a fall away of the percentage of women until we reach this fairly miserable statistic of 1 in 5 of full professors in the UK across all subjects are women. And of course, this is the opposite for men here, to make up to 100%. Now, these plots are full of confounding variables and are a bit of a worry when it comes to actually trying to persuade people that there's an issue, because they say, well, there's all sorts of factors which contribute to this, including some really odd statistical quirks like Simpson's paradox, which you may well have heard of, which is at the bottom. There's a reference to it at the bottom there. Or that this is a dynamic problem that will change with time, or that it doesn't reflect the people who leave the profession, and there are all sorts of things there which could very quickly lead people to not believe that there's an issue. What we found was useful was to use these data not in as single point data, but to plot these over time. And you notice here that there's a red line and there's also a white line, and the white line, which is slightly difficult to see, forgive me, is at an earlier date than the red line here. And what we've been using these, so there's, I think it's 8 years difference in these two lines. What we use these data is, the way we use the data is saying, well, there are confounding variables. However, over time, if we're being successful at gender, in our case, gender equality, we would expect those numbers to change, and we'd expect them to change at a particular rate. And if they didn't change, then indeed there is a problem. So it's not the fact that the data don't necessarily report on the nature of the problem, but if they don't change, it tells you that the problem, there is a problem, and in this case, not disappearing. And you see actually the progress in gender equality for high-level faculty staff remains extremely slow in the UK, and these type of time progression data now are being used to, again, push the cause of equality more strongly. Lastly, I just want to very quickly show you this set of data here. Now, I just need to unpick this plot here. This is the pay gap. So the y-axis is the pay gap. What is the pay gap? The pay gap is in percentage, and the way you calculate the pay gap for an institution is to take the average pay of a man, average pay of a woman, beg your pardon, subtract the average pay of a man and divide it by the average pay of a man in the institution. So a negative value here, shows that on average, men within the institution are paid more than women overall. And each of these lines that you see in the plot, each of these vertical lines is a particular university here in the UK. And here's my lovely little institution. This is the University of York, and we have a pay gap of minus 15%, which is something I'm not very proud of. But each of these other lines is a different university in the UK. Now, normally when I give a live presentation to a live audience, I say, where do people believe? So before I ask this question, so the bigger pay gaps are down here on the left, and the small pay gaps are on the right. Where do people believe the universities of Oxford and Cambridge sit in this set of plots? And rather interestingly, people always point down to this end of the plot, saying those institutions would have worse pay gaps, gender pay gaps, than institutions that are at this end. Rather interestingly, I ask at that point, why do people believe that the more well-known institutions would have worse pay gaps? And it's an interesting question in itself, and we use that particular trick, I would say, in the data to convince people that they may well be holding biases. I should tell you that Oxford and Cambridge actually don't do too badly at all. They're all around this region here, and these particular institutions down here are quite are not the ones that you might expect. By the way, if you're interested in those institutions who have zero pay gap, they are small liberal arts colleges, mostly in London. So I show you these data for a different reason, though, and that is this. This is the median pay gap for chemistry professors. So these are full professors in my department. Now, I have to say here, the data the other way around. So a positive number here is a pay gap in favor of men, just as the previous plot was, although the number there was negative. And you notice here, and this was for us a really strong index of being able to drive forward gender equality. You notice that we published these data within the department over time, and you notice that when we began looking at these data, well, you won't notice it from here, but what we said when we began publishing these data says we're going to set a target of equalizing the pay gap to 0 over a period of, well, in this case, it was about 10 years. And you notice that indeed we achieved that, and we achieved that by publishing the data in the department, saying what we thought the causes were, but committing ourselves to closing the pay gap to this 0 figure. And there were 2 factors in this which I think would help us be successful. The first is we published the data and committed ourselves to closing it, so everything was available. And secondly, we set a target, and we set a target over time and expected that to progress over time. And this is my kind of final point to this particular set of data here, is that time-based data for equality measures, in this case it's the pay gap, are powerful. When they're not time-based, a single snapshot in time, they're not so powerful. But when they're published over time, where we expect things to change, then for us, those became powerful uses of data. So I'll finish right here. Hopefully I'm on time. We have collected baskets of data, for instance, the percentage of people at particular grades and pay gap data. We've also supplemented those with qualitative surveys and brought them together to be able to say the following: they all tell the same story. And in many cases, we've understood that there are confounding variables there, and then in those cases we've taken those data as indices, but use them over time to expect that those indices would get better. And on that basis, those 2 for us were powerful. So I'm going to stop there, and I'm looking forward to the questions a little bit later on.
Thanks so much, Paul. That was great. Just as a reminder, if folks have questions, please type them in the chat box that's on the right-hand side of your screen, and we'll follow up with a discussion after Danny. So with that, it's my pleasure to introduce our next speaker, Danny Caballero. Danny's an associate professor in the Department of Physics and Astronomy and the Department of Computational Mathematics, Science, and Engineering at Michigan State University. He holds the Lappin-Phillips Chair of Physics Education, co-directs the Physics Education Research Lab, and is principal investigator of the Learning Machines Lab, which is a joint collaboration between folks here at MSU and folks at the University of Oslo in Norway. Danny earned his bachelor's degree in physics from the University of Texas at Austin and his master's and PhD from the Georgia Institute of Technology. Danny worked as a science teaching postdoctoral fellow at the University of Colorado Boulder before joining the faculty at Michigan State. His research focuses on computational education and the use of data science to address questions in STEM education. Specifically, he's been recently involved in using his team's research to drive change for the physics graduate degree program at MSU, which he'll talk more in detail throughout his talk today. So with that, I think I will turn it over to Danny. to share his screen.
Okay, I think you can see the whole thing right now, right? How about now? Great, awesome. Well, thank you for the introduction, Rachel. Thanks to the topical group on data science for the invitation to talk with you all today. I'm excited to share with you some of the work that we've been doing at State around issues of diversity, equity, and inclusion in graduate physics programs. So this is sort of a bit of a detailed example following up on a number of the ideas that Paul shared with us in his talk, which was wonderful, and sort of shaping the sort of larger challenges that we have ahead of us. So I want to start by talking a little bit about our goals for doing this and just kind of get us all on the same page. So we have three sort of principal goals around this. We want to increase the proportion of folks from underrepresented groups in graduate physics programs. We want to also support their transition into professional careers. In the US, the way that we think about this is with regard to women, racial and ethnic minorities, LGBTQ folks, veterans, first-generation students, people with different ability statuses, and all of the intersections thereof. So it's a sort of a wide range of folks, as Paul alluded to. We also want to create structures that remove barriers for folks and promote their full participation in our program. That is a key element to the work, and it's a challenging thing to do in a large department like ours. And then finally, we want to reshape the culture of our department to bring these folks that have been traditionally excluded into critical activities and decision-making processes. And the thing that we would like to do as a result of all of this is to sustain these changes over the long term. And I think Paul's last slide is really indicative of this, is the idea that you collect data to investigate how this is going, and you continue to iterate on it as you go forward. So the sustaining of these changes isn't just continuing to have them go forward as they exist at the moment, but to think about them and continue to make changes to achieve these goals. So it's very common to talk about diversity, equity, and inclusion with the acronym DEI. I want to unpack that a little bit because that involves us better understanding both our goals and the changes that we try to make to our programs. So I'm going to use definitions that are from the Berkeley Division of Equity and Inclusion. Diversity is the way we think about different identities that people can hold at the same time. These would be, like I said, race and ethnicity, gender expression, etc. This is the thing that people are talking about when they're thinking about graduate physics programs in terms of increasing the representation of people in those programs. Equity is the way that we guarantee fair treatment, access, and opportunity and advancement for folks, and striving really to eliminate the barriers that prevent full participation in the activities of the organization. In terms of a graduate program, it would be the participation in that program. Inclusion is thinking about how we bring in folks that have been traditionally excluded into activities and decision making, and giving up power to share it more broadly and ensuring equal access to those opportunities and resources. So these are different things, and so when we start to think about how we address them, we are thinking about different kinds of programs and different kinds of sub-goals within that. Rachel's actually given me a really great analogy for this that I'm probably going to mess up, but I'm going to try it anyway. If you think about a party and having a party, the analogy would be that diversity is everyone is invited to the party. Equity is everyone can contribute to the playlist for the party, and inclusion is that everyone is provided with the opportunity to dance, right? And I think that's a really nice analogy to help us think about distinguishing between these three components. If we get into graduate physics education in particular, I'll give you a couple of examples around these changes that one might make. So with regard to diversity, we might be thinking about changing the representation of applicants and admitted students by actively recruiting at the Society for the Advancement of Chicanos and Native Americans in Science conference or the National Society of Black Physicists meeting. If we're thinking about equity, we might be thinking about changing admissions criteria to remove barriers for applicants. Some of those exams that folks have to take are very expensive, for example. We may also think about creating structures that support the transition to graduate physics programs, something that the APS Bridge program does. With regard to inclusion, we might think about creating a governance structure where graduate students can participate in and vote on departmental decisions, or implementing a departmental code of conduct and the associated accountability practices, right? So while all of these are important, they sort of fall under different ideas with regard to DEI. So because we were asked to talk a little bit about evidence, I want to talk a little bit about the ways that we generate evidence around these issues, and then how we've used that evidence in our department. So it's common, certainly, to start with this idea of informal or anecdotal evidence. This is, what we hear from folks and what we remember from history, and it can be subject to our own biases. And actually, I think the issue really is that it can be subject to centering our own perspectives with regard to that evidence and how we use that evidence to make decisions. When I think about the research that we do in my field, I think about qualitative research as a tradition that allows us to provide evidence, typically from individuals in small groups. And the object of that research is rich descriptions of those experiences that are rigorously vetted and triangulated. So you move beyond the stuff that we hear and the stuff that we remember to stuff that we can write down and connect across different data sources. Quantitative research is a tradition that provides us evidence typically from large groups of individuals, and this lends itself to statistical analysis and modeling of this data. And we often generate claims and counterclaims to investigate these data to be able to say what they actually mean. In our field, we also use mixed methods research, which is a way of blending both qualitative and quantitative approaches to generate complementary evidence. So for example, you might use quantitative research to understand what's going on in a large group of individuals, and then follow up with qualitative research to understand the details of what's going on for folks in those groups. So like Rachel mentioned, the field I work in is STEM education research, and I work with the Physics Education Research Lab and the Learning Machines Lab, and we study a lot of different things, but the main goal of our group, in particular the Learning Machines Lab, is to generate quantitative evidence for understanding these issues in STEM education. So when we look specifically at graduate admissions, we're trying to understand what kind of quantitative evidence can we develop from the data that we are able to collect. So I'm going to show a couple of plots that talk about graduate admissions and from the American Institute of Physics. So if we look at the percentage of PhD earned by women in different scientific fields over the last almost 40 years, we've seen that there are more women earning PhDs than there have been in the past, and that trend has been upward. But if we specifically look at physics, the number of women who are earning PhDs is still around 20%. If we then look at folks who are African American or Hispanic American, we're counting specific numbers of people on a 2-year average. So the number of African Americans earning PhDs over the last about 20 years or so is around 15 or so on a 2-year average. There's been a little bit of a jump in the number of Hispanic Americans. In fact, the year that I earned my PhD, the 2-year average was close to about 13. So what you can see just from these two plots alone is with regard to the share of PhDs granted to women and granted to folks from racial and ethnic minorities, we have some challenges ahead of us. And what I want to focus on specifically is the admissions side of this. So if we look at the numerical markers that are used for admission, this is work that comes from a colleague of mine, Casey Miller, we can see that there's a difference in the distribution of GRE physics scores for women and men, and there's a difference in the distribution of GRE scores for folks from different ethnic groups. And what you find, certainly from this graph, is that women tend to score lower than men, and folks who are Hispanic and who are Black tend to score lower than their white and Asian colleagues. What's interesting about this study that Casey did was that if you then look at how those factors, like GRE scores and undergraduate GPA, predict the completion of a PhD, they aren't factors in that in those completion probabilities. It turns out that men and women of a wide variety of GPAs and GRE scores tend to complete their PhDs with the same probability. So these numerical markers that we use for admissions are really not predictors of the completion of a PhD. In addition to that, Geraldine Cochran and others have studied that students are aware of this bias in the GRE, and some see it as a barrier to even applying to programs in the first place. And so, there's some really deep implications there with regard to how we signal the use of the GRE in our admissions processes. In particular, the Educational Testing Service themselves signal that these subject tests can help students stand out from other applicants. And my PhD student, Nick Young, and I investigated this with a set of data that we have from 5 graduate institutions. And we found that on, sort of all metrics for which we have data, that it really doesn't help students stand out. Here's a plot showing a comparison between the largest undergraduate programs and the smallest undergraduate programs, where students have applied to PhD programs. And this phase space is showing you the undergraduate GPA and the BIN GRE physics score. And what we find is that students with high GPAs and high GRE scores tend to be admitted to programs more than sort of the average, and students with lower ones do not, and there's not much of a distinction between larger and smaller programs. In addition, Nick did an analysis on this called a moderation analysis, which basically showed that if you account for the institution size, the physics GRE scores can explain some of the differences in admission probability, but they don't necessarily fully explain it, and they don't really indicate to us that scoring highly on the GRE helps students from smaller or less selective schools stand out. So let's take Michigan State as a case. So Michigan State is a large institution. We have 70 faculty, about 200 graduate students. We receive about 300 PhD applicants per year. We admit about 60 students per year, and we end up having about 30 of those students join us per year. So we admit about twice as many students that actually accept. And this is not atypical. We are a large high research activity program, like many large research high activity programs across the United States. Prior to 2018, our admissions process was pretty standard. Applicants submitted their transcripts, their GRE scores, statements, letters, etc. And a spreadsheet organized those materials, and a large committee, 10 or 15 folks on our faculty, reviewed the applications. And just like many institutions, we used a soft cutoff for the GRE. And if we look at the population of students who were admitted to MSU, about 15% of those in fall of 2017 were women, and about 7% were identified as being a racial or ethnic minority. Prior to 2017, we didn't even record this information. So what's interesting there is a commentary on how we thought about issues of diversity with regard to our graduate program if we didn't record the folks who were being admitted. Now, what my student Nick did was he took some of this data and he looked at admissions using a random forest technique to predict whether a student was admitted to the program or not. And what he found was that he can predict about 80% of the admitted students using only their physics GRE score and their undergraduate GPA. On the left, what you're seeing is a feature importance plot that shows that the top 2 features in his analysis are the physics GRE and the undergraduate GPA, but the next 2 are also GRE scores. On the right is a phase space showing you what his model predicts and what the data say about the admission of a student. And you can see a sort of red boundary there where students were not admitted, which are lower GPA and lower GRE scores. Now, what's interesting about these GRE scores is these cutoffs, because a lot of schools definitely use them. Nick and I worked with a student, Nils Mikkelsen, to investigate what these cutoffs effects can be and what they're sort of connected to. So again, using a random forest technique, Nils looked at did an analysis of data on 5 different graduate programs, and looking at a variety of factors and what the important features were given a wide variety of cutoffs. And what he found was that GRE cutoffs, sort of regardless of the range, tend to favor students with high GPAs, large schools, from large schools, and male candidates. The other factors didn't really matter so much in terms of the cutoff. So this kind of evidence helped us have a discussion among our faculty about what the process looked like and how we might change it. So in the fall of 2017, we invited Julie Purcell to study his graduate admissions to give a colloquium. This book that she has is excellent. And with Casey Miller, she ran a workshop on graduate admissions rubrics and how to do a more holistic evaluation of candidates. So we developed a rubric, and we admitted our first class in 2018 using that rubric. Now, the rubric itself has a variety of different pieces, and I'll highlight them here. 25% of the rubric focuses on academic preparation. Another 25% focuses on research experience and the skills that a student has developed. 25% focuses on non-cognitive competencies like conscientiousness, initiative, perseverance. 15% is about fit within the program, basically the group's needs and whether how the student would be an advocate for diversity, and 10% is GRE scores. And by making that change, what we see is that the fraction of admitted students who are women increased significantly. Last year, we admitted our admitted class was 35% women, and the fraction of folks who are identified as racial or ethnic minorities increased to 15%. And just as a reminder, this is about twice what we had prior to moving to this holistic rubric. So I don't want to tell you that we've solved all of these problems, but rather that this is a case for changes that we've made towards our diversity goals. And I haven't spoken a lot about equity or inclusion because there's still lots of work to do. We've now admitted students on a different set of evaluation metrics. And so that first year experience needs to be retooled because we want to focus on the transition to graduate school. What we value in students is different. And so we need to align our first year experience with those values. The pathways to PhD candidacy requires us to reflect on those goals and begin to offer some alternative pathways, removing barriers for students and allowing them to fully participate in our program. As we start doing this, we will continue to collect evidence and study this to look at degree attainment. And as a unit, we're trying to address systemic sexism and racism throughout our program. There's a paper here talking about the experiences of women in physics that's worth reading. We've developed a diversity, equity, and inclusion committee that's working on addressing these issues, that's working on making recommendations, and that is working on developing a code of conduct for us to be able to hold ourselves accountable around these issues. And one of the nice things is that we've recently joined the APS Inclusion, Diversity, and Equity Alliance to get more ideas from more folks around these issues. So if you take away a few things from this talk, I'll just finish up here. I want you to take away that these traditional metrics don't align with our diversity goals, and they don't predict the completion of PhD programs. The GRE scores don't help students stand out, and the cutoffs, even soft ones, are problematic. The admissions rubrics that codify what we value can help us increase our diversity, but there's still lots of work for us to do regarding equity and inclusivity. Thanks so much.
Thanks, Danny. So with that, we have about 15 or so minutes. So just as a reminder, if folks have questions for either Danny or Paul, to put them in the chat. And we will, Kyle and I will monitor all of your questions. But I think we want to kick it off with a question for the both of you. If you could have everyone in the audience do one thing to help address these DEI challenges within the field of physics, whether that's at the department level or more broadly, what would it be?
You go first, Danny.
Okay, thanks. So I guess I'll speak to that from the perspective of graduate physics programs, because that's what I know. And so my suggestion would be to really try to work on understanding what you value in graduate research and trying to build your program to value those things. Because when you start to reflect on those values and you start to construct something like a holistic admissions rubric, right? You start to really begin to address these issues of diversity, equity, and inclusion sort of by default, because our values are ones that value diversity, equity, and inclusion. And we have just been working in a space where we've continually perpetuated the same tools that we use to judge admissions criteria and to judge, performance, and those things don't really align with the success of graduate researchers. And so when you start to do that reflection work and you start to build those processes, I think a lot of these things will begin to change, and you start to have really productive conversations about what that program can look like and what kinds of things will lead it to be a stronger program.
Okay, for me, it would be 2 words: speak up. And that is that when the moment comes, and whether it's in a meeting or in a setting, and you see someone being marginalized, spoken over, you name it, speak up, call it out. And it's the hardest thing in the world to do, but goodness me, does that make a difference? So yeah, that's what I would say.
Great advice. So we have a question for Paul from Dirk Joster. Paul, could you please provide more information on the basket of indices? I'm particularly interested in what data we should be collecting.
Yeah, so I'll very briefly, we collect male-female data on pretty much everything that moves. So it's just broken down. So graduate admissions, undergraduate admissions, broken down different graduate program. And in fact, these data are publicly available. If you go on the Athena SWAN, ATHENA SWAN, SWAN site, the data that we collect is actually publicly available, and our progress against those. We also collect pay data, as I mentioned to you. And we also have 2 other sources of what you might call qualitative data. The first is a general staff survey. The second is that we do what we call a culture survey in the department. And again, if you search for culture surveys, you'll find that there's a particular set of questions you can ask in a particular way, which will reveal whether there's an issue with culture. And what is culture? I would say is the day-to-day kind of interactions that people have with each other, and whether that's a positive culture or a less positive culture. So there's that basket of data that we collect over time and then monitor over time, is which feeds our decision making.
And I guess for you, Danny, do you have any insight onto what data we could be collecting at our own institutions to try and answer some of these questions?
Yeah, I think that the talk that I showed you shows that you should collect information when you can, right? So if you're talking about graduate admissions, you should try to hold on to most of that information, because what happened basically between 2016 and 2018 is we had a transition from one graduate coordinator to another. And the second graduate coordinator collected and held on to more information to be able to help us understand what was going on. And the previous one did not, and that is lost, right? I can tell you about who's currently at MSU in the graduate program because the registrar holds that information, but I can't tell you who applied and was admitted in the past because we didn't keep that, right? That's not necessarily so. I think the idea is to over collect, right? What you can, because you don't know whether it's going to be useful for building your DEI initiatives or not.
That makes sense. So for Danny, has the physics jury effectively been ended by the ETS? Their test developer staff for the physics jury disbanded? Question mark. You know?
I do not know. So my understanding, I've talked to a lot of places, and there's sort of a general sense that the physics jury is not a particularly productive tool for predicting these kinds of things like earning PhDs and so forth. And it's expensive. But because of the global pandemic and because that test is given in person, the dates have all been canceled. And so most graduate programs that I have spoken to have basically said, well, the GRE is optional this year. And this has maybe also facilitated some institutions to really consider not bringing it back. So it's, as I understand it, it still exists, but it's just not being offered this year.
Just a question for Paul here from the chat. So from Jerk Joyster, for the million paper analysis that you mentioned, how was mean group ethnic diversity determined? I would say, broadening that a little bit, how do you actually go about, quantifying diversity as you get more and more potential categories?
Yeah, it's a good question. You'd have to go back and look at the details of the paper. The ethnic diversity, I think, was done on the country of origin from which the authors claim their affiliation. The gender diversity was done on first name correlations with known databases. I think both of those are, of course, imperfect, as you might imagine. And I think it goes back to the point I was trying to stress, is that there will always be factors in there which would bring a question mark against whether what you're collecting is really fully defendable. The answer is it probably isn't, and this is why stressing the change of these indices, and let me call them indices, over time is a powerful way of not necessarily ignoring those question marks, but expecting progress against it despite the question marks. So it's a great question. I don't have a perhaps very compelling answer other than to remind you that we approach these data pretty much as viewing them as indices. In fact, I think in the paper they actually do call them indices, perhaps to reflect that.
So just another question, kind of building on this idea of different types of diversities. Many different groups face DEI issues within the field of physics, and both of you talked about programs, for say particular groups. What are your thoughts around implementing policies to support these diverse groups? Is it a scenario where we're at a stage where we need diverse policies, or do you think it's possible to create holistic policies that address many groups at once?
Shall I go first, Danny, and then you can have a crack at that one too?
Yeah, go ahead, Paul. You go ahead.
Thanks, Danny. I'll be brief. I think the stance we've taken over the years is to actually answer that question with another question, and that is, where is the evidence base for making progress? And in the past, the evidence base has been built up largely for gender or gender inequity, and we've been building our policies based on that. And indeed, that's a single kind of dimension, equality, but is the most robust basis on which to then bring in interventions. Over time, though, the evidence base has expanded towards, certainly in the UK, towards ethnicity, getting more data there, and also LGBT and disability issues. And as a result of that, we're now able to examine other dimensions with an evidence base behind us. And my comment there would be, some of the solutions we had from the evidence base for gender are different to the solutions that we're applying in different dimensions. And so to take a holistic view, I think that was the word, expecting single solutions work is probably not in accord with the evidence base.
Yeah, I think I would agree with Paul. I would build off of it a little bit too, to bring in an inclusion angle, which is that if we're going to be trying to address these inequities and these systemic barriers, we have to bring in folks who experience those things into the process to make those decisions together, right? I think the holistic framing of it misses the angle of what Paul said. Each of these groups of folks are experiencing different issues around inequity and right. So I think the to add on top of that is bringing in folks to have those conversations and discussions about what kinds of changes need to be made, and to share the power among all of the individuals that are making those decisions.
Yeah, thank you. And just to say that at this moment, we thank you everyone for your question. We do have 2 more, and I'd like to try unmute you for your question. I see Philip and Gabby have both submitted questions, and now Philip, I will try to unmute you and see if you can ask your questions live.
Hi, I want to thank you, for great presentations. So looking at it from the high school student point of view, student contemplating taking physics, the data are I think actually really bad starting at that level in terms of DEI. And I'm just wondering how the data that you presented today could be presented and discussed with young high school students to encourage them to take the chance and the risk to take physics.
Sorry, Dan, you're probably better qualified than me on to answer this one.
I got it. Yeah, no problem. That's a great question, Philip. So you're right, and I think if you're interested, if folks are interested, you can look at the American Institute of Physics collects information on the different groups of students who are taking high school physics and what kind of high school physics they're taking. But I guess what I would say is I wouldn't want to characterize it as a pipeline issue, right? That is a flawed metaphor for what we're running into, because it goes back to this idea of creating a culture across all of the physics offerings, right? All of physics that brings everyone in to be a part of it. And so the question about how do we do that at the high school level is a challenging one, because it's often the first experience students have with physics. There are some programs like Step Up for Women, which is an APS program to help give high school teachers tools to be able to address this from a gender perspective. At the moment, I'm sort of blanking whether there are other resources through the American Physical Society for this along other dimensions, but that's the resource that I can think of at the moment. And there's a lot of folks associated with that have a lot of expertise around this.
Thank you.
Yeah,
and thank you. Let me move on and squeeze in one last question for this session. So I see a question coming up from Gabby. Let me try to unmute you and see if you can ask your question live. Oh, oops. Gabby, it looks like your mic is not set up, or you have muted yourself. Yeah, there.
Can you all hear me?
Yes. Hi.
Okay, hi. Thank you both for amazing presentations. I'm a graduate student in my physics department, and there's been a move that's mostly been led by students and a handful of faculty to become more equitable and inclusive. But we have been meeting resistance from other faculty who just haven't taken the time to learn. I'm assuming it's not malicious. And I'm wondering if you have any suggestions for, like, me personally as a graduate student, what I can do to kind of move things along faster.
Well, thank you for your own efforts, I have to say, and your own passion. That's perhaps the first acknowledgement to make. I mean, that's fantastic to hear. If I was to draw an experience, the resistances I found are either people just deny there's a problem, and of course the data help enormously there, and so our session today I hope will encourage you to collect more data. Then they think it's not their problem, they're not the root of the problem. Then some unconscious bias awareness raising we found has been helpful in some cases. And then the next resistance is, why should I care about it? And that there we have found the data I showed on the million papers and their positive effects on academic culture certainly for us triggered a debate which converted a few of the remaining naysayers into saying, okay, no, I can see how equality, or equity rather, is connected to academic quality. And there won't be everybody won't convert with that. And in my experience, about 10% of any cohort is just going to be against it, full stop. But you do have a chance with some of the data I think we showed today that to convince some people to come over to the argument. Danny, you probably have some good ideas there too.
Yeah, I mean, Gabby, your question's a really deep one. It's really tough because what you're talking about is trying to make change happen in sort of an organic way. And there's certainly some resources on institutional change that may be useful there. That's the lingo for it. But what you're trying to do oftentimes is to identify the levers of power that you have access to, or that people that you are working with have access to. So I can't tell you a specific answer because each institution has different kind of factors or levers, right? But I can tell you, like at MSU, for example, one of the major levers for us is actually the dean's office. It turns out that our dean is very, very interested in issues around DEI. And so when these kinds of things come up, right, the lever is basically to get organized around the dean's office and exert that positive pressure from the college onto the department. So there may be similar kinds of levers for you at your institution, but it would require some research on your part, or maybe on the part of the group that's doing this, to figure out what those positive pressures can be.
And with that, we're going to have to wrap up. Thank you so much, everyone, for attending. Thank you, Paul and Danny, for your interesting talks. And I hope that this will be the start of ongoing discussions in the GDS on equity, diversity, and inclusion, and how we can use data to continue pushing forward these important issues. So thank you very much, everyone, and I hope that you have a pleasant Friday afternoon and enjoy your weekend.
Bye, folks.
Thank you very much.
Thank you, everyone.
Thank you. Bye.